Hello and welcome to the Mixed Concepts channel. This will be a bit different compared to the content on my channel. This is actually a math video. So, based on the title, it says, what if the chain rule didn't exist? Something along those lines. So here, I'll be taking the derivative of 2x plus 3 to the third power, or 2x plus 3 cubed. Let's just rewrite it a little better than the text. So this is basically what I want to take the derivative of, 2x plus 3 cubed. Now with the chain rule, it's not that hard. First, just use the exponent rule. So basically, you would multiply 2x plus 3 times 3. And then you subtract 1 from the exponent, so 3 minus 1 is 2. And then because it's using the chain rule, you multiply the inside of 2x plus 3, the derivative of 2x plus 3, which is just 2, because the derivative of 2x is 2, and the derivative of 3 is 0. And at the end, all we got to do is just multiply the 3 and 2. So it becomes 6 times 2x plus 3 squared. Now you can definitely leave the answer like this, but I am just gonna multiply it out. So what's 2x plus 3 squared? Of course, don't forget the 6 in the front. So 2x plus 3 squared is just the formula, very famous formula of a plus b whole squared equals to a squared plus 2ab plus b squared. So 2x squared is 4x squared, now plus 2ab, so 2 times 2x times 3, so that will be 12x, and then 3 squared is just 9. All that multiplied by 6, and now I'm just going to distribute it. So at the end, the total answer is 24x squared plus 72x plus 54. So that is the derivative of 2x plus 3 to the third power when you multiply everything out and leave it in polynomial form. So this is pretty simple when there is the chain rule. But what if you don't want to use a chain rule, or what if it wasn't known? Then the derivative becomes a bit harder. So I will write it down here. So now this is the equivalent of saying 2x plus 3 squared times 2x plus 3. Now, if you do know the formula of a plus b cubed, then you can go ahead and do it. I actually don't know it, so I'm just going to do it this way. So we got to remember to keep the d over dx, because I'm not taking the derivative yet. So we just figured out what 2x plus 3 whole squared is, so I'm just going to rewrite it again, which is 4x squared plus 12x plus 9, and then multiply that by 2x plus 3. I apologize for my poor writing. I'm just using a mouse. I'm not actually writing it down, just using a mouse and trying to write it out. Sorry about that. Yeah. Alright. Now, just to distribute it, so it would be d dx of 8x cubed plus 12x squared plus 24x squared plus 36x plus 18x plus 27. So that's what happens when you distribute it out. Okay, there are some like terms to combine, like the 12x squared and 24x squared, and the 36x plus 18x. So on the next line, I will draw it. So basically we're taking the derivative of 8x cubed plus 36x squared plus 54x plus 27. So now it's just pretty basic to take the derivative of this. Just using the simple power rules, we'll get the derivative of 8x cubed is 8 times 3, so that's 24, x to the 3 minus 1, which is x to the second power, so 24x squared. And now the derivative of 36x squared is basically 36 times 2, so that's 72. And then x squared minus 1, so x to the 2 minus 1, which is just x to the 1, so it's 72x. Then the derivative of 54x is just 54. And the derivative of 27 is 0, because the derivative of any constant is 0. So there we go. Got the same answer without using the chain rule. Of course, if I did remember the a plus b whole cubed formula, it would have been done much quicker than this, but I didn't remember it. But that's fine. Still got the right answer. And then you can obviously decide to convert it back to 6 times 2x plus 3 squared if you want to. But otherwise, you can leave it at this form as well. Alright, so that's the way to take the derivative even without the chain rule. It is definitely a longer process, but it can be done. However, if the exponent was 7 or 8, then we got to thank the chain rule, because it would be such a pain to try and find the derivative of such a function. Well, I will make a part 2 to this where I actually will solve the derivative without actually using any of the derivative rules, so using the definition of the derivative, which is the limit. I will be solving that in the next video, so please do watch that whenever I release it. And until the next video, bye. Thank you for watching as well.